Hello everybody, this is Dr. G. Today we are going to go over 2019 free response question number 4. This is a related rate problem. A cylindrical barrel with diameter 2 feet contains collected rainwater. In the figure, the water drains out through a valve at the bottom of the barrel. The rate of change of the height of the water is with respect to time t is given by this function, where h is in feet and t is in seconds. And they also give us the volume of the cylinder, the formula here. So for part A, find the rate of change of the volume of the water, V, with respect to t when the height is 4 feet. So indicates the unit. So for part A, V of t equals pi r squared times h of t. So in this problem, you have to identify what is a constant. So in this problem, if you look at the figure here on the right, on the left, r, d equals 2, so r equals 1. So we can plug this in, pi times h of t. So both the height of the water and the volume of the water, they are function of t. So when we take the derivative, we want to find the rate of change of v. So it's dv over dt. We can take the derivative with respect to t on both sides. So now we can plug in dh over dt, negative 1 over 10 square root of h. So this is the equation for dv over dt, the rate of change of the volume of the water. So they are looking for the rate of change at h equals 4 feet. dv over dt is negative pi over 10 times square root of 4 equals negative pi over 5. And the unit, because the volume, the unit here we use feet, so it's cubic feet per second. Part B. When the height of the water is 3 feet, is the rate of change of the height of the water with respect to t increasing or decreasing? So we are trying to study the rate of change, increasing or decreasing. So first, let's have a look. What's the rate of change of the height? So the rate of change of the height is dh over dt. So if you want to study the rate is increasing or decreasing, we need to take the derivative. So we are taking the derivative with respect to t again. So this will become the second derivative with respect to t. So dh over dt, so we have to use the chain rule. First, we take the derivative with respect to h, 1/2, 1 over square root of h. Then we take the derivative of h with respect to t. So this equals negative 1 over 20, 1 over radical h times negative 1 over 10 radical h. Now we have to simplify a little bit. This is cancelled. So final answer, 1 over 200. Because the derivative is always positive, so the rate of change of the height is increasing. Let's look at part C together. So for part C, at t equals 0 seconds, the height of the water is feet. So at t equals 0, h equals 5 feet. Use separation of variables to find an expression for h in terms of t. So given dh over dt equals negative 1 over 10 square root of h. So separation of variable, we move all the variable with h to one side and move everything with t to the other side. Next, we take the antiderivative on both sides. So on the left side, when we take the antiderivative, we'll have 2 square root of h. And on the right side, we'll have negative 1 over t, 10 plus this constant c. Be very, very careful. Don't forget a constant there. So now we are going to plug in the initial conditions when t equals 0. When t equals 0, h equals 5. So 5, 2 radical 5 equals 0 plus c. So c equals 2 radical 5. Now the function is this. Now we just need to solve for h. So square root of h equals negative 1 over 20t plus radical 5. Then square both sides. Squared. This is our final answer. I look at their rubrics. 2 points, 3 points, and 4 points. Part A, dv over dt. This part, 1 point. Final answer with unit, 1 point. Don't forget the unit here, okay? Part B, this part, 1 point. This part, 1 point. And your explanation, 1 point. So that's 3 points. And the last one, when you split these two, that's 2 points. Constant, 1 point. Final answer, 1 point.